Thank you for the introduction, team. Again, as I said, the presentation will be mostly an overview of CTC rather than going into technical details, because we are still a very young research institute, and it's quite a unique opportunity to actually build a research institute from blank sheet of paper, especially in Germany. And I think our experience might be interesting to some people in the audience or somebody who would be watching the recording afterwards. So the institute is called Center for Transformation of Chemistry, and one of our priorities is focusing on automation in research, in chemical research. Okay. How did CTC started? So it started roughly around 2021 in COVID times, when German government, they published call for abstracts for funding of 2 new scientific centers. And the goal was to support development of regional economies. And so Professor Zieberger and Matthew Pluchak, they were 2 originators of the idea. They applied and they won the competition. And the competition provides 1.2 billion euros until 2038. So that's a really long-term project. But the first stage, just to secure this funding, was to succeed in a startup phase with a primary goal to set up the administrative structure of CTC, which means things like human resources, IT, legal department, procurement, etc. And this department had to be set up within 2 years, while we were working from under umbrella of Max Planck Institute. But now we succeeded in that, and we have our own administration, like in a big institute. But our scientific team is still growing, and it's growing really quickly, because now, since the startup phase is done, we are focusing on real research. And our ultimate goal is to have up to 1,000 employees total in 2 locations. Why 2 locations? Because we are supported not just by German government, but also by 2 regions. But again, the main goal for this funding was to promote growth in the region and creation of new jobs. And what could be better than creation of innovation driven jobs like chemical research or institute. So we are based around Leipzig, and Leipzig area and in general Saxony and Saxony-Anhalt is famous for chemical industry, for really large chemical facilities such as chemical park at Leuna and neighboring chemical parks. But this is a very old industry, and it's in a dire need of upgrade and renovation. And in general, there is more than 30,000 employees in the region, and they bring up to €500,000 revenue per employee, which is a really good number. But in the light of worldwide competition, companies need much more innovation than just relying on old infrastructure from GDR times or even older. So that's where CTC comes in, and we started active phase of hiring roughly in 2033, when we've been just 3 people, and now we are around 60 or 70 employees across 2 locations in Leipzig and in Delitzsch. And that's this map shows the area of chemical triangle, where with the Leuna industry park here, and you have really amazing chemical industry around. So why do we have multiple sites? Because we are sponsored with 10% from 2 regions, from Saxony and Saxony-Anhalt, and therefore we have to contribute to both of the regions. And currently we are planning to have a campus in Delitzsch and 1 campus in Merseburg. Those will be permanent locations where we will have to build new buildings, new research facilities. But until they're built, we are temporarily occupying the laboratories in Leipzig, and that's a absolutely new building where we still have to do repairs. And another building which is being constructed as we speak is a chemistry innovation lab in Delitzsch. Sorry. Oops. So the driving idea behind CTC is to help not just grow the economy of the region, but also transition from environmentally unfriendly, let's say energy sources of fossil fuels or coal that has been dominant in the region, and transition into more circular economy, where you try to reuse as many products as possible within their supply chain. So cradle to cradle approach is the ultimate goal. And to do that, we have two big driving ideas. We call them moonshots. One idea is a fully autonomous laboratory, and a second idea is a fully recyclable car, which both idea, they come synergetically to help not just change what we do with chemistry, but also how we do chemistry. So in terms of what do we do in chemistry, we are looking at a fully recyclable car project, which is, you can arguably say that right now cars are also recycled. You can recycle steel, you can recycle tires, maybe in asphalt, you can recycle aluminum and other components that come into the car, but you might overlook a lot of little details which come into small pieces, such as adhesives, some internal materials. You might have sealants and coatings, and electric engines with rare earth elements and lubricants, and all of them need to be recycled in order to create a fully recyclable car, not just partially recyclable car as it is right now. And with a transition from internal combustion engine vehicles to battery electric vehicles, you have much higher level and complexity of materials, and it creates additional demands on recycling. So that's a scientific kind of frame for the research in CTC. But how we change it, we are trying to transition from old ways of doing chemistry, which arguably haven't changed too much since 100 years, into more modern, automated discovery machines or discovery engines or laboratories with automated lab moonshots, of which I will talk a bit later in the presentation. But coming back to CTC, what is the timeline currently? We have successfully passed the startup phase, and now we are working as an independent institute. We have an independent legal entity, and we moved to this office building, which I am in right now, and you might actually hear some drilling in the background because people are still doing repairs on these floors below me, but I hope it doesn't interfere too much with the presentation. Currently, we are in a really active phase of recruiting both scientists, technical personnel, management, and all sorts of employees just to support such a big project. And we have recently closed the applications for research positions, but new research position applications will come next year. And currently plan to open the laboratories in autumn this year. So how the more detailed timeline looks like, we started with 3 different sites because of the logistical reasons: in Golm with Max Planck, in Delitzsch with where our current administration is located, and in Leuna where we had temporary offices. Now we have moved to City Labs Leipzig, which are pretty close to center of Leipzig, where we have temporary accommodation with laboratories. Then we will open new laboratories in City Innovation Labs in Delitzsch. And in yellow, you see our 2 permanent long-term sites, campuses in Delitzsch and in Merseburg, where we will have different profiles of research. So probably a bit more automation in Merseburg and a bit less or more manual chemistry in Delitzsch. This is how our laboratories look right now. This is a picture on the left, which I took just yesterday. But we are planning to build as it's a temporary location, we are not planning to build something extremely fully integrated and automated. We just need a really robust, good, reliable laboratories for now. But more automated laboratories, more integrated laboratories, they will come later on the permanent sites. So how is the organization structured? We have a really interesting and maybe slightly different organizational structure to other research institutes, where we put an emphasis on supporting young researchers with all that we can bring from the cutting edge of IT and technology, and but they will have only limited time contracts. So we are planning for up to 40 research groups with fixed term contracts of up to 7 years, and these are again the thematic areas for science that we are focusing on. Again, automation, data-driven chemistry, recycling, renewable feedstocks, which contribute to fully recyclable car moonshot, and environmental and sustainability matrices, SEAM, which help to evaluate how environmentally friendly technologies are and how they contribute to the sustainability of research. And currently we have some mini pilot projects which are focusing on small parts of each of the topic. This is a talent factory, but we also have a core department with permanent positions for professors who could have their own groups, and that would be permanent kind of research groups. Additionally to scientific departments, we also have really amazing support infrastructure in the shape of Service Hub, which provides analytics support, so analytical chemistry support, digital infrastructure support with DECO, and lab planning and operations, who are currently really busy on preparing the laboratories for us. And this is a direct support to the researchers with chemistry, but we also have a tangential support in terms of education and technology transfer with Technology Transfer Office and Academy for Chemistry Transformation. So I'll come back later to all these departments in a little bit more detail in the presentation. But I wanted to start with data-driven chemistry, represented by Sasha Tinius, who are focusing not only on data-driven chemistry, where you try to use vast amounts of existing data or data coming out from the experimental machines, but also trying to do ab initio simulations and seeing how computational chemistry could help making new discoveries. So these are two main focuses of this department. And then we have data engineering and computing team, which supports data-driven chemistry department and automation department in terms of providing data management, software and data engineering, and scientific and computing for researchers. So the goal is for scientists to come to an existing well-polished architecture for uploading the data and managing their data that they bring with them or that they generate in the laboratories. This is a rough representation how data infrastructure would look like in CTC that supports both experimental research and computational research. But all of the data, the key feature of the system is that all of the data would come into the single unified data set and with a single query interface, so that you could seamlessly review data which has been generated, whether it was in the laboratory or whether it was created on a computer. Another societal, environmental, and economic matrices department, represented by Pooja Dwivedi. She focuses on multiple different parts of evaluating those matrices around the existing research or existing materials that's already that might need to be replaced or might need to be evaluated. So first of all, tracking progress, how sustainability matrices across and internally in CTC work out, then quantify the impact of the research, review the performance of research projects, and also guide the directions for young group leaders who want to focus on this topic as well. So the core technology to assess every metric is to use sustainability assessment and particularly life cycle assessment for materials. And that's a current focus right now, because this is something you can already do without actually needing to do experiments, because the life cycle assessment is can be enabled computationally. Then another department which supports young group leaders is Academy for Chemistry Transformation, or ACT, with Tony Grell and Marcus Lange. And the goal for this department is to provide education at different levels of, let's say, careers or education, starting from school students at Pupils Lab with vocational training, and then jumping into a graduate program, helping PhD students and postdocs, and then on to assisting junior research group leaders, and as well as local employees from local companies. But importantly, we skip here master's and bachelor's courses, because CTC is not a full institute, so it cannot teach degrees. And for the degrees, this could be done only with joint collaboration with other universities. Okay. And also another important department is Technology Transfer Office, with Sarah Keels and Matthew Pluchak, who are focusing to be as a service unit for researchers with business aspirations, or when you see potential in the research they're doing to become profitable or commercially interesting. And really, it's meant to be an end-to-end support, from business idea development to intellectual property management, coaching, as well as marketing of the ideas. And again, this team is also still building and posting some job advertisements. And currently we have one group leader, Dr. Laura Koenig-Matten, in computational biorefining, with her PhD student team, Tegmeyer. And they are focused on lignin functionalization. If you think of it, if you think of lignin parts as building blocks, which create the chemical space from which computationally you can try to see what kind of molecules or what kind of materials you can generate, and also look at a top-down approach, starting from specific materials or properties that are achievable, that are needed, and trying to go down and seeing what kind of molecules are needed for those. And the beauty of this project is that it can be also done computationally, and you don't need laboratories. So that's why they can work productively right now, even without laboratories. And coming back to my topic, an autonomous laboratory, one shot. We are currently a team of 3, Eric Sletson, Samuel, Victor Saraiva, and myself. And again, our goal is to transform how chemistry is done, not just looking at what you want to do with chemistry, but actually how to do it better. And obviously, you would want to introduce as much automation in the laboratory as possible, thus accelerating research, making it more reproducible and productive. And the beauty of CDC is that we are starting from a blank sheet of paper, and on the left you see one of our permanent locations in Delitzsch. That's an old sugar factory. You can say it's an empty plot of land where we can design a new building which would be suitable to automation or other research initiatives. But that's a really unique opportunity you probably get once in your lifetime. But the ultimate goal is to create an AI native architecture, or especially with an emphasis on unification of devices, to which I come later. I'll describe later. If you think of scientific research, it's always about closing the loop between idea generation, carrying out experiments, and data analysis. And then a really nice mental model for this was presented by Alan Asper-Guzik in his paper in 2024, with different levels for laboratory automation. It's by no means an ultimate, let's say, classification of automated laboratories, but it's still an important model just to see where chemistry automation is in general right now, and also how software and hardware automation interplay between each other. The holy grail, of course, is the level 5 of automation, where you have fully automated hardware and you have a generative software which can synthesize new steps and execute those steps automatically. But we are still really far from that, and arguably you might not need to reach level 5 to have a really good productive laboratory. So I would say currently laboratory automation is somewhere at the level 2, where you have maybe automated single iteration of experiments in software, and all tasks of experiments are usually also automated, such as, let's say, analytics or reaction automation, etc. But you're still quite far from fully automated chains or processes in the laboratory. Okay, but why I said that we might not need level 5 automation? This is because there is always a balance between flexibility and productivity in any process you might imagine, not just in a laboratory, but also in factories, in production environments. Even in biology, you could say there are organisms which are really well fitted towards their environment, which are really fast or really productive, right? But they wouldn't work as well in other environments. So if you take a shark out of the water, it wouldn't be an apex predator anymore, right? It would be just a fish. So in our case, in the laboratory, you can think of it as if you start with manual workflows, with fully manual workflows, you can do pretty much anything with your hands. So this is an ultimate flexibility. This is the highest flexibility you can get with experiments. But also you want to increase productivity. So how do you increase productivity? By introduction of robotics. And you by adding any type of robotic system in your workflow, you lose flexibility step by step. And if you go to a fully automated, fully integrated laboratory, by definition, it wouldn't be able to do as much stuff as a typical wet laboratory with chemists. But on the positive side, it would be really quick, really productive, really reliable, and with really highly reproducible results. So this spectrum is a guiding, let's say, principle whenever we have internal discussions about the software we develop or types of hardware we need to buy. And we always try to put ourselves somewhere on the spectrum, where we need more flexibility or where we need more speed and productivity, right? But arguably, chemical automation and automation in a laboratory is inevitable. Why is it inevitable? Because critical masses of inventions enable technical breakthroughs. And one amazing example of this, which I like to present, is invention of neodymium magnets by Sagawa Masato in late 20th century, so not too long ago. And in my opinion, it's one of the undervalued inventions in almost our lifetimes, which changed the world around us. So those magnets, what they enable really high magnetic fields without electrical input. And this enable creation of really high torque motors, which can act as joints or parts of movement systems. And those movement systems right now enable robots, electric robots that can do all sorts of amazing things. And this is an example of how this seemingly uh, seemingly simple invention created such a big change in technology that we see right now around us. And arguably, we have something like this happening in chemistry as well. Uh, and in chemistry, I think what represents a critical mass of invention is digitalization of devices. From really complex devices such as reactor systems to more and more simple and more mundane things like balances or pipettes, or even maybe slightly even unnecessary, but things like digital storobars, which are absolutely miniature, and they can allow you to see the data from inside the reactor. Um, and this is a really critical mass, but the combination of all those inventions still haven't led to a really breakthrough in the laboratories that we see. We, of course, we see individual devices, but we haven't seen a really change of work how we do chemistry. So, in my opinion, this really big change will and have to come from a real operating system that can universally combine all devices. And one such historical example, again, is the Windows operating system. So in 20th century, when they were competing with Mac, with Apple, right? They represented absolutely different philosophies of development of computing systems. While Mac was fully integrated system with proprietary code and specifically developed hardware that only worked on Mac computers, Windows signed agreement with manufacturers to open up the drivers and actually allow different manufacturers to create their own drivers that could plug and play into the device and into the operating system, thus enabling this vast market, not only of the periphery devices, which could be connected and interoperate with Windows machine, but also the internals of the computer was also made by different vendors. So how does this drive our philosophy in CTC? Uh, and again, we are trying to close the discovery loop autonomously, right? So we're trying to introduce as much automation into every step of the scientific process. One can argue that yes, still the process automation or science automation or research automation has existed since really a long time ago, but which you can see, example of which we can see on the right side. But this represented only a one-off, let's say, device or one-off workflow, while we are aiming for a really universal system that can not only help you digitize the automated workflows, but also bring the researcher into the loop, not just to refine the goals, but also to help do some experiments and digitize the results that being produced by researchers in a machine readable form. And operating system which is universal and which is able to connect to all the devices in the laboratory is really a vital piece in this puzzle, and it should be able to handle every step of the process. So since we don't have laboratories right now, this is our main research topic and research focus. Unfortunately, cannot show too much right now, but one project that is being worked on is by Samuel in from Max Planck Institute, who built on the existing package of FlowChem, which is also developed in their laboratory. But what he created is he created this also operating system, but not very universal, which is targeted mostly for flow chemistry experiments, but arguably it can help researchers automate any type of flow chemistry experiments. I'm not sure. Yes. So on the left side, you can see creation of a flow protocol where you can drag and drop pieces of flow instruments such as valves, tubes, pumps, etc. And on the right hand side, you can see actual operation of the device, where it can work both in the simulated work as it is right now, highlighting the flow paths, the connectivity between instruments, and also this can connect to real devices and drive real devices, which they actually practically use for a lot of practical applications in the laboratory. And the system is based on a modular approach, where they have a protocol, which is a high-level process, high-level, let's say, unit, which combines different processes, and which is then broken down into processes, modules, and commands. So you could manually edit every kind of level of this automation, for example, with Python scripting, or you could recombine different processes together to create new protocols out of existing scripts. So this is a really flexible system and also user-friendly. It's still unpublished, but you can already see the documentation on the internet with this link, or if you Google Chem United. Yep. So this is it for automation part. And for the conclusion of the presentation, I just wanted to highlight that we are organizing a summit in Leipzig called Transforming Chemistry Summit on 15th and 16th of September with a really amazing lineup of speakers. So please check it out and register. Registration is still open. So please take a look at this. And to keep updated with what's happening at CTC, and there's a lot of things are happening, you're encouraged to check out our website, LinkedIn, and the newspaper. And we also post a lot of job advertisements right now. So thank you for listening, and I would be happy to answer any questions that you might have.